part of for loop again. I started recording the lecture, and then let me open this. Okay, and now what I'd like to say about the homework, I've seen there's new submission of homework number 8, if I'm not mistaken, homework number 8, and just one submission. Maybe Ben, you submitted it, right? So I mean, I did grade it others, but yours one I gotta grade it, like, since I just saw it. So, yeah, it's all right. It's all right. I was just saying, like, I'll just need to wait a little bit for this grading for the homework number 8. Homework number 9 is due today, right? So yeah, you do have time. Just submit that homework number 9. So basically, by this week, I should be able to. Sorry about that. By this week, I should be able to grade all those homeworks, right? Number 10, homework number 10, and the practice 10, both are uploaded in practice test. Okay, so you should be working on that due next week Wednesday, week from today. So now come back to our original topic. This is the for loop class number 3. Okay. Ideally, it should be done with the for loop. Okay. But today we should be studying the while loop. But don't worry, these are very straightforward stuff. I can actually finish both of them today as well. But I don't want to rush anything. If you feel like that you guys are up to speed and everything with no issues, then I'll gonna do it. Okay, like both of them together. Huh? Huh? না ওটা লাগবে না না ওটা লাগবে না 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 ওটা লাগবে না 3 নাম্বার না ওটা ম্যাটার 1 নাম্বার তো দিছি চাকরির জন্য হ্যাঁ ওটা রিপ্লেস করো আর কিছু না আমি ওরা জিজ্ঞেস করছি যে ওটা রিপ্লেস করো 2 নাম্বার লাগবে 3 নাম্বার আর 1 নাম্বার হাফ হাফ করে যদি চাকাচাকি থাকে তাহলে 1 নাম্বার চাকাচাকি না থাকলে অনলি 3 নাম্বার বাদ সব বাদ সব বাদ বললাম তো খালি 3 নাম্বার সরি হ্যাঁ খালি 3 নাম্বার all right, so let's start. Okay, so for loop. Uh, so week. So for loop. Let me put it this way. For loop. Part 3. Title. You understand? I'm sorry, I didn't get it. Good.
Week 10. I was just asking.
Oh yeah, it's week 10. I'm sorry. Yeah, it is week 10. So you can say this is title. Okay, week 10, lecture 2. Okay, how about that? Title description. So we'll be doing improving the speed of loops. Okay. And the CLC, clear, close all, okay, all those things needs to be there as it is. You know the meaning of them, right? The main code, and then the example one. Okay, the first example. So example one is adding the prime number. Okay, so before I start anything, let me focus on today's topic. So today's topic is to understand and learn how to increase the speed of the funnel, right? How to make it computationally efficient is the key word that people use. Computationally efficient. Okay, computation trusted. All right, so adding the prime number. So then let's start with the description. So prompt. The user to enter a value below which to add together all the prime numbers. Use the primes function to generate the prime numbers. Okay, so that's the problem description. Basically, we'll be using the prime function to generate some prime numbers first, and then we're gonna run a program which is gonna add those prime numbers. That's the goal. Okay, first we would like to define a variable called max. Okay, what is this max is doing? It is gonna get the input from the user to give you the highest number of the prime number. So you wanna put this way: please enter the value for the highest prime. All right, say like you'd like to define the prime number from 0 to 200, so you'd like to put 200 here. Okay, moving on. So you'd like to define another variable called nums, and then you're gonna use the prime function, which is prime, and use the max, which is primes, by the way, I'm sorry, primes, and use the max in the argument. So max is already user input for the max number. Then you are generating a matrix by this. So you are generating a matrix of prime numbers less than max. Okay, and now you're gonna start to write the for loops. So you're gonna start with a variable called total, and by doing that you are initializing variable for summing values. Okay, and on the for loop nums. Okay, remember in the for loop you are using this lamp function just like before, right? To get the max of this nums value. What does max means? So nums variable obviously has all prime numbers up to the max number, right? So like at 200, all the prime numbers is going to get stored on the nums, and the nums is a matrix. So you'd be assigning how many elements to the matrix by using the len function. Does it make sense? Daniel, do you understand that? I know the need to sometimes catch up.
Is that a J next to the
It is a J. It is a J.
So what's the difference between the J and an I? Because I saw the I.
Yeah, so you've seen probably using the J, I, K, and all these things. It doesn't really matter. You
Oh,
can
it doesn't
use.
matter.
It doesn't matter. You can use that. You can use it.
Okay.
Does it make sense? As a variable. So anything. I mean, but usually in for loop people use I, J, K. There's I, J, K element. Okay, this is standard. Been seeing it over my whole life. People use that. Okay, so okay. And then remember the total variable. So you would be using that as like total equal to total plus this nums j. Okay, and then what we'd be doing here, obviously you want to put a semicolon here, don't want to display it. You are adding the jth prime number. Now this thing, Ben, you might be finding it a little difficult to understand, but this is what we've done before, right? So basically once you define some variable at the beginning of the before the for loop at the beginning of the program, and then you can add the values by doing this command like total equal total plus the new value. Every time the for loop is going to run, the new value is going to get stored, and the total variable is going to get updated every time the for loop is going to run. Make sense? Stand so far? All right, moving on. So then then you'd like to display the result f printf I'd like to announce something. I won't be here on April 15th. April 15th there is a class. I have a conference. I'll be going North Carolina. Okay. So okay, the sum of the primes is, don't worry about the syllabus. The syllabus can be finished very easily. Okay, not that much. We have very small number of students, so we can catch up easily. And did I announce the final exam is take home already? Final exam is take home, right? Okay, but it's due on the exam week, not like you can finish it in week 14. It needs to be submitted week 15. Okay. All right. So that's that. And then you'd like to save it and run it, I guess. So this would be week 10 lecture 2, and then run it. You should be seeing it's asking you some value, say like it's 50, and the sum of the prime is 328. Okay, so now other interesting thing that you can do is like you can type nums, and it should be showing up to 50 what are the prime numbers, right? Do you guys all have it similarly? And I've been talking about fprintf pretty much every day. Everybody's okay with the fprintf, right? And fprintf has like this percentage of f, percentage of s. If it's percentage of f, then if you're gonna define it like 0.0, that means you are not taking any fraction. You are only talking about the integers, right? So that's what the display for fprintf about the percentage of 0f. F is for fraction, but it's like no fraction values. It's only the integers. And this percentage refers to the pointer where the value of the variable is going to show up, right? And once you're done with this text single quote, then you must put a comma, put the variable name where the percentage that you are referring belongs to that. Anyway, so that's the first example. I might be able to finish that. All right, the next one. Example number 2. So let's try to understand how long it takes to run a loop. So you'd be using tick and talk to time a loop. Okay, so you'd like to do this CLC clear all. Okay, so clear all. Then we'd like to define n equal 1 million. Okay, this is the number of times for the loop to execute. Then you'd like to use this tick. Tick is a command. You guys remember the difference between command and the function? The command is like CLC, clear, close all, hold on, right? So we used those things before, right? This tick is a command as well. It's not a function. All right, so tick, that's the start timer. This is start timer. Then you'd like to write the for loop for I equal 1 colon n, then yi equal I square. And it's absolutely need the absolutely need the semicolon y. What is the n? A million. If you don't have a semicolon, what will happen? A million times it will gonna show up, right? All right, okay, absolutely need that, right? Because writing into a command window is very slow process. Okay, so and also it's writing it in command window is very slow process. So because writing info to the command window is a very slow process. Relatively speaking. Okay, now the slow and fast is relative thing, right? And then you'd like to end it and you're going to say talk. So note if you get stuck whenever you are dealing with this big number, right? What to do? Click in the command window and press control. Press control plus C. Okay, what we're gonna do, which will end the process. Okay, I'm gonna save it, run it, and see what happened. You see, now the cursor is blinking, that means the program is running. You gotta understand, it runs 11 times, 1 million times, and it takes like 3.14 seconds for the program to run. All right, the TikTok does that, it counts the time. So TikTok, those are the commands. Okay, remember that those are the command, not the function. All right, now this one still take a little bit time, right? If you're gonna improve it, how are you gonna improve it? Any suggestion? Improve the time, computational time. You may want to predefine the matrix, right? Remember, that's what we were learning before. Okay, so let's do that. So we are trying to improve the efficiency. So can we improve the efficiency of the loop? Can we do that? Yes, definitely we can. We can do by doing it clear all, right? And define the same n or capital N equal 1 million, right? And start with tick, and then you define this y variable where this y should be nan. When you remember, nan means not a number. Yeah, not a number. I did talk about it. And then once matrix, you remember that. Remember the once matrix. It creates all elements by 1, and what we're doing, predefining the matrix. So it will gonna improve the efficiency, means less time we're gonna take. Okay, memory or the RAM does know where the elements of those matrix are already before running the program. Okay, that will improve. Okay, and yeah, I know. You go ahead, watch the video lecture. Okay,
I will.
okay, this will make an n by 1 matrix of ones multiplied by an. Okay, again an is not a number. Okay, then you're gonna write the program for loop, right? For sure. So for, again, it could be anything ijk. Let's start with I again. 1:n yi equal I square, and then we're going to end, and then we're going to do talk again. You are basically doing the same thing, TikTok, right? But this time you are pre-signing. It will gonna even take less time for today's class. I know you can have been speaking good also. My voice, you see, yesterday I couldn't even talk. I gotta come because if I don't come, then he's gonna fall behind, right? I gotta come because I have so many things. Like next 2 weeks later, I gotta go to conference. If I miss, then you guys would be in trouble.
The April 17th conference, is that the ASAA conference or is that another one? Because I have a conference that is the
Not-
ASAA.
No, this is not a conference. This is actually a ABEC conference in person.
Ah,
You know ABEC?
I've heard of it, yeah.
Yeah, ABEC, all our programs are
Amen.
ABEC accredited. So I've been in charge of one of the programs ABEC. Okay, so big talk over for one day only. I could have go for the whole week. I'm just going for the main thing, what I need. Okay, but I'm going like on 14th. I'm coming back on 16th. So that means you'll be missing one class, right? Tuesday's 14th, right? Yeah, Tuesday's 14th. Yeah. Yeah. I'll be going on Tuesday and coming back on Thursday. Alright, so moving on. TikTok. Running it. So 200. So now the time get improved a little bit. Did you see previously it was 3.14, 3.04 now. It got improved. Okay, so that's the clear evidence here. So why is the second method is faster? The reason is that we have predefined the result matrix. Okay, which is the first method. The matrix is growing within the loop. All right. Okay, why is the second way is faster? Okay, I was talking about that. With the first method, the matrix is going within the loop, and the MATLAB has to, or Octave has to redefine its size on every iteration, and it takes time. With the second method, rather than redefining the size of the matrix, it simply replaces the n with calculated value. This is much faster. You probably won't notice the difference in speed until you're doing a calculation with more than 110 to the power 4 or 110 to the power 5 values, right? So basically you are dealing with this 1 million value. That's why you're seeing the difference, right? But if it is like a small number, you won't be able to see any difference at all. So bottom line, this NN is helping you allocate that memory space before running the program, so it makes the program faster. So that's the bottom line. Okay, that's all you need to know. So let's move on. You see the second one elapsed time is 1.42. I'm sorry, I thought like it is like 1.04, but the first one is 3.04 and the second one is 1.42, which is much faster, right? I mean, as you can see, I was explaining, so again, so for the second one, with the first method, the matrix is growing within the loop, and Octave has to redefine its size on every iteration. That's the first one, and it takes time. With the second method, rather than redefining the size of the matrix, it simply replaces the n, not a number, with the calculated value. This is much faster. Okay, I think I have said enough. Let's move on. So we do have one final one, which is example number 3, which is projectile motion with pre. I can actually finish even part 4, but I don't want to do that because only you are here, 2 of them are missing. So let's finish this and then we'll call it a day. Okay, so projectile motion with predefined matrices. So let's define the constant. So ay equal minus 9.81, and then ay is, you remember that, right? The acceleration, gravitational acceleration is the unit with meter per second square. The acceleration due to gravity in y direction. Okay, and I'd like to define the givens. So what are the givens? Obviously theta equal to 15. Theta is in degree, right? There's the angle for throwing. Okay, the projectile has an angle of 15 degree. The initial velocity VO equal 180. The same problem what we did in last class, right? A little bit different way would be doing by initially defining the matrix, right? So that's the technique. So pretty much the same thing you can actually copy from the previous lecture as well. This part what I'm doing now, okay, with the unit of meter per second. There's the initial velocity, and this initial location in x and y direction, xo, which is the unit of meter. So this is the initial x location, right? Then initial y location. I'm doing a little changing, just copying it, and the t matrix, right? The time with interval of 0.1 to until 10 seconds, and then the unit is obviously in second, and it's your time matrix. So again, as I'm saying, we'll be doing that same problem as like last class, right? We've been predefining the matrix by n once, the thing that we just did before. All right, so let's do that. All right, so initialize x and y result matrices. The matrices where x and y position will be sorted when they are calculated in the loop, right? So in other words, your x and y, right? Those things you'd be defining. All right, so NaN 1 comma length t, and then y. I'm basically following the same thing, you know, defining a once matrix where the length is the function used to define the max number of elements in T matrix, right? The time matrix. For both x and y, you just follow the same, and then you would be defining the initial x and y velocities based on theta and v0, right? So let's do that. So you'd be initialize x and y, or say determine initial x and y velocities. Hello, man, what happened? Velocities with my typing. Velocities based on theta and v0. So vx equal v0 multiplied cos t theta, and then the unit is meter per second. Okay, and then this is your initial velocity in velocity in x direction, and then I'll be copying that for Vy. Sin d, this is in y direction. Alright, then it's time to write the for loop. So we just define this matrix, initial matrix, we just define the x and y component of the velocities. Alright, let's write this. So for loop. So write the loop to use a different time value on each iteration. What is that? So for I equal 1 colon, sorry, so 1 colon length, the same pattern, like, you know, length t. So this will repeat for however many values are in matrix T, because the length function is going to deal with that, right? You know that. Okay, so then you have this x and y position based on the time t, right? So it'd be calculating, so calculating x and y positions based on t, and then you have xi equal xo plus vx multiplied ti, right? And the unit is meter. This is your x position. Okay, yi equal yo plus vy multiplied ti plus 0.5 multiplied ay multiplied ti square. You know why you can put a dot, because it's the single element. Dot is for the whole matrix. Alright, if I typed everything correctly, that means it should be working fine. So then the unit is meter, and this is your y position. Alright, so then reminder, these are the equations we used for the plane problem in homework. Okay, we've done it before as well. So then there are the equations, right? Homework number 4. Remember those equation, I did write it in last class as well. So which is xo plus vx. Only thing different here, initializing the matrix, okay, t, and then obviously don't forget to put the percentage or comment, and the y is equal yo plus vy multiplied t plus half of y multiplied t square. Those are the equation, right? And then you're going to simply end the for loop. Okay, and then obviously you'd like to display the results, right? That's the plotting. So plot the solution. So you have this plot function for sure. You have x comma y, and just like last class, you can define o as an indices, and k is for black color, and then you can do anything, literally change it. So you can do line width maybe. So line width, and then you can define, say, like 2 line width, and X level. So you have this X level is X in meter, right? And Y level is the same. So it's in Y in meter, right? And then the title, right? Title is path of projectile. That's it. Save date, you run it, it should be running fine. Alright, so there's a typo. It should be Y0. Yep, it's running now. So if you typed everything correctly, the projectile motion should show up, right? Alright, start working with the homework, I guess. Okay, ask me any question if you have any, and I'll see you again next week.